Okay, this is starting on the second integration sheet, the homework problem number 1. And for the first few, we're supposed to verify by differentiation that the formula is correct. And the first one, it wants us to basically prove that the integral of x divided by the square root of x plus 1 dx is equal to the square root of x squared plus 1 plus a constant. Alright, and so anyway, we'll get started with that. So we should have, or set it up, that f of x is equal to the square root of x squared plus 1 plus a constant. Alright, and so that is the same thing as x squared plus 1 to the 1/2 plus a constant. So when we take f prime of x, I should get the power rule. So we bring down the power times what's inside, subtract 1 from the power, so it's going to be basically negative 1 plus a half, so it's going to give us negative 1/2, and then times the derivative of what's inside, which is 2x, and that's plus the derivative of constant is 0, so that's going to be 0. And so now basically go ahead and do the calculations. So that's going to be 1 over 2, and since it's negative, we have put, since the x squared plus 1 is to the negative 1/2, the negative just tells us to put it in the denominator, so we're going to have x squared plus 1 to the 1/2 times 2x, and then we have our plus 0, so we just leave that off, and then when you multiply that out, you're going to get, because you just multiply straight across, and that's the same thing as 2 over 1. So we have 2x over 2 x squared plus 1 to the 1/2. Okay, so here was where we left off as far as calculating everything from the last slide. Okay, so as you can see, those 2's are going to cancel each other out. So we'd be left with x over x squared plus 1 to the 1/2. And since we're taking the derivative, you know, we have the dx out there as well. I've just been leaving it off because the derivative of x is just 1. So, but you need to know what you're taking it in respect to, so I'll plug that in at the end of it, but you can go through and track everything down. But anyway, like we said, that x, and that's going to be over, and whenever something's raised to the half power, you're going to take the square root of it, x squared plus 1, and like I said, you know, since we have taken the derivative and it's been in respect to x, you can put your dx out there. And if you remember the initial problem, it was proved that using differentiation that the integral of x over the square root of x squared plus 1 dx was equal to the square root of x squared plus 1 plus a constant. And if you go back and double check everything, you will see that we proved that right there by taking the derivative of this and getting our original back. So that one works out.